Hi, and welcome to the notes for 4-4. In today's lesson, we are going to practice finding values of trig functions using the unit circle. In the previous lesson, we reviewed how to find the sine of theta, the cosine of theta, and the tangent of theta on a unit circle. And just remember that, we had that diagram that looks something like this. We had our unit circle, and then we were talking about if we had some angle theta, right? And theta would be like an angle coming, in the standard position here right now. And so since it opened up like that, we could draw in our right triangle that's formed, and we're talking about some point P, right? Or any point along the unit circle. Okay, we'll call that point P, and it has coordinates X and Y. And we knew then that we could always find the Y value of any point by looking at that angle, right? That central angle that opens up. Okay, we call that our theta angle, and so the sine of theta is always going to equal the y coordinate of any point P on the unit circle. We also know that we could find the x coordinate by simply taking the cosine of theta. And then we talked about the tangent of theta is always going to be equal to the ratio of y over x. It's like the slope of the hypotenuse of that angle. Or you could also just treat it as the sine of theta over the cosine of theta. Let's move forward. So this is what we call the 1, 2, 3, 3, 2, 1 reference angle chart. And we are going to just quickly review how to create it if you want to use it to help you find your exact values of some of these trig functions. So if we're looking at this one that looks like a big tic-tac-toe board almost, okay, this part of the reference angle chart, we're going to take it here and we're going to say our smallest special angles, which are the pi over 6. Then we've got our middle-sized ones, pi over 4, and then pi over 3. It's the same thing as 30 degrees, 45 degrees, and 60 degrees if you're doing it as degrees. And then we're going to go on the left side, sine, cosine, then tangent. And we call it 1, 2, 3, 3, 2, 1 because that's how you start building it. 1, 2, 3, 3, 2, 1, 3, 1, 3. All these boxes at the top of the top two rows are all over 2. Just think about on your unit circle, they're all over 2 when you're looking at the unit circle. And then we'll take the square roots of the tops. And you could even write the square root of the 1, but really there's no need to do that. Square root of 1 is 1, so you don't need to write the square root of 1 on there. But it would still be correct if you did draw it on there. And then we have the square root of 3 and the square root of 2. Now notice, it's not the whole entire fraction, it's just the numerators. And then when you get down to the tangents, okay, if you think about this on the side here, right? If we said sine divided by cosine, it should equal tangent. So if I took 1/2 divided by radical 3 over 2, and we took it and we simplified it, what we'll end up with is the square root of 3 over 3. I just like to think about the fact that, this second fraction has a radical 3 on the top, so we have a radical in the denominator of the entire fraction. If you thought about it as a big fraction, 1/2 over radical 3 over 2 ends up being radical 3 over 3 after you've rationalized the denominator. Okay, but then in the middle, right, we have the square root of 2 over 2 divided by the square root of 2 over 2 is going to equal that 1. Maybe I'll make that 1 a little bit bigger. And then on the end over here, where you see we've got the square root of 3 over 2, this is under the pi over 3 angles. We've got square root of 3 over 2, that's a 2, divided by 1/2, right? Well, think about it. If we just multiplied each of them by 2 over 2, or the value 1, we get just the radical 3 is being the answer. So that's what this one's just going to be, just the square root of 3. All right, so we use that, and you don't have to, draw out all this extra stuff on the side that I just did. They're explaining it when you're doing it. We also want to know the values of our x's and y's, whether they're positive or negative. And that's where we use the one that looks like a big coordinate plane here. Just remember, in our first quadrant, right, all of our points are going to be positive, positive. So the cosine is positive, the sine is positive, and then that would make the tangent also positive. So they're all positive in quadrant 1. We've got negative, positive in quadrant 2, which means that our cosine and tangent are negative, and our sine is always positive. In quadrant 3, our points are negative, negative, which means that our sine and cosine are negative, but that would make our tangent positive. And then in the last one there, we have positive, comma, negative, which means our cosine is the one that's always positive in quadrant 4. All right, so we can use this now, and we didn't use it a ton at the end of the last lesson, but we started to. So it says, find the exact value of each of these. We have the cosine of 4 pi over 3. And you see I have a bunch of really small ones listed on there, just so I don't have to keep flipping back and forth. But I'll flip back and forth on this first one so we make sure we understand how to use this. It says the cosine of 4 pi over 3. So when I jump back and I think about the cosine of 4 pi over 3, okay, so we're looking for, our angle is going to have a reference angle of pi over 3, and then we're looking at the cosine. So find the cosine, and then find the angles that have a reference angle of pi over 3, and then where those come together, you'll see we have 1/2. Okay, so we know the value is going to be 1/2, and then what we're also going to look at here is what quadrant is 4 pi over 3 in. Okay, so what quadrant is 4 pi over 3 in? Right, and if you have to take it and draw it out, that's fine. You know, you can just take it here and think about, well, as we go around here, we know this is 3/3, and then 4 pi over 3, we know it would end up being down in here. And that's not even drawn to scale, right? I mean, it'd probably be more, one would be probably more down here, but just know that it's in quadrant 3. So when we think about that, the only function that's positive down in quadrant 3 is the tangent. So since we're looking at cosine, right, we know that it's going to be a negative 1/2. So we'll take it here and we'll write it in as negative 1/2. Okay, so the next one here, we have sine of negative pi over 3. Okay, so here's why I had the little ones drawn in here, and you don't have to draw these little ones. You can always refer back to your big chart. I just don't want to jump back and forth. Okay, so sine of negative pi over 3, when we think about it, right, I'm talking about my reference angle is going to be the pi over 3. And then since I'm talking about sine, I'm talking about this top row. So we're talking about this one here. So when you think back to what that looks like, you know, on yours, you'll see radical 3 over 2 up there, right? So I know it's this one here. I know it's going to be a radical 3 over 2. And now what I also have to think about is what quadrant is negative pi over 3 in? Well, when we know that we've got our 4 quadrants, if we went backwards, pi over 3 would be down here in the 4th quadrant. So remember, the only positives down here would have been our cosine values. So since we're doing sine, we know this is a negative radical 3 over 2. Okay, how about tangent of negative 7 pi over 4? So first of all, we know that this is a pi over 4 angle, and we're talking about tangent. So we're talking about right down here. And if you recall in your 1, 2, 3, 3, 2, 1 chart, this is a value of 1. Okay, so we know that this is going to be a 1, but we need to figure out positive or negative. Again, think about your angles. Negative 7 pi over 4 means we're almost going all the way around the circle like one whole time, right? Think about our fourths. If I drew in my fourths and actually counted them for you, right, we're going to use all of these. We're going to go back 1, 2, 3, 4, 5, 6, 7. We end up in quadrant 1. And remember, everything is positive in quadrant 1. So this answer is just going to be positive 1. All right, the next one, you see sine of 3 pi over 2. Well, the sine of 3 pi over 2, we can't really use this, right? Because 3 pi over 2 ends up being right down here, right? It's like 1.5 pi. So it's at the bottom of the unit circle on the y-axis. Remember, this point that you see down here is the point 0, negative 1. So we're talking about the sine. Remember, we're talking about the y-coordinate down here. So we're going to have a value of negative 1. Then we go down to the cosine of 13 pi over 4. Okay, so again, we've got sine, cosine, tangent. So cosine is in the middle. And then I'm talking about pi over 4, right, is our reference angle, so it's in the middle. So we're talking about this one here. And we know in there that is, what we'll see is a square root of 2 over 2 on our reference chart. So now we need to think about where is 13 pi over 4. And if you want, you can take it and draw it out. Remember, with fourths, we will count our y-axis because it's an even number. And I want to break it into fourths, so we need our 3 diagonals. Now I've broken it into fourths, so I can count my way around. I'm going to go 1/4, 2/4, 3/4, 4/4, right? I'm going to go all the way around. Here's 8/4, 9, 10, 11, and 12. And now we're going to go down here. Here's 13 pi fourths down here. So we are in quadrant number 3. And remember, cosine in quadrant 3 is always going to be negative. So we're going to put down here negative radical 2 over 2. And then the last one here is another one where you won't need this because we're talking about a whole pi value. Okay, so when we're drawing out angles on the unit circle, anything that is an odd pi, right, whether you're going in the positive direction or the negative direction here, when you get on this side, it's going to be an odd number of pi. And when you get back over to this right side, it'd be like an even number of pi. 0 pi, 2 pi, 4 pi, 6 pi. On the other side, 1 pi, 3 pi, 5 pi. So if I went in the negative direction around here, right, if I went in that negative direction, okay, this is where I'm going to end up on the x-axis on the left side. So remember, that point, it's easy to mix up your zeros and negative ones if you're rushing, so don't. Right, I have negative 1, 0. And if I'm thinking about the tangent, tangent is going to be equal to y over x. So I'm going to put 0 over negative 1, which is just 0. So our answer there is 0. All right, so the more you do with these, the more you practice them, the better you get at finding, those reference angles and the positive and negative values. Let's move on. Let's look at some notations here. We talked about this briefly the other day, but let's just talk about it one more time. When you see something that looks like this, where we've got the sine of theta in parentheses and it's squared, remember, this means the same thing as sine squared theta. Okay, I think it's written more like this, and this is just my personal belief. I don't know the exact reason that they came up with this notation, but it makes sense. The way that my teachers have always described it to me is when we don't want to write it like this, because some people would end up writing it like this, and then they think about, oh, am I squaring the angle measure? We're never squaring the angle measure. Okay, so that's why we write sine squared theta, because we're going to take the sine of theta and then we will square it. Okay, so don't square the angle measure, square the sine of the angle measure. It says, evaluate each of the following without a calculator. So this one says sine squared of 2 pi over 3. So we're going to think about this as being the sine of 2 pi over 3, and then we're going to take that value and square it. That's what this means right here. Well, when we think about the sine of 2 pi over 3, right, if you think about your reference chart here, we know sine is the top, and you would have looked at it and said, oh, we're using pi over 3, which is over here on the right side. So we're talking about this value you see in this top part of the reference chart. And we know that in there, that should be a radical 3 over 2. Okay, so the sine of 2 pi over 3 right now we know is radical 3 over 2. And 2 pi over 3 is in the second quadrant, so we know it's positive. But in this case, it really won't matter if it's positive or negative, because if we are going to square this, right, we're going to square the top. The square root of 3 squared is 3. Since it's positive, positive squared is still positive. And then when we square 2, we get 4. Our answer here ends up being 3/4. Okay, let's look at the cosine squared of 2 pi over 3. Okay, so again, this is like saying cosine of 2 pi over 3 squared. And since we're talking about the same angle, right, this angle being up here in the second quadrant, we said, it's right up here. We've got the point radical 3 over 2 for our y value, and we know that the x coordinate then has got to be a negative 1/2 up here. So as we take this and we write it out, right, we're going to think of this being negative 1/2 squared. Well, negative 1 times negative 1 is going to give us positive 1, and then 2 squared is going to give us 4. So our value here is 1/4. So with these special angles, we can always do it without a calculator. If we have an angle, though, that does not appear on our unit circle, or one of our special angles anyway, for instance, at the bottom we have finding the sine of pi over 11 squared. Okay, so this one down here is what we're talking about. Sometimes we have to use the calculator. So when we take it and we try to put it in the calculator, we're not going to type it in the same way we see that there. Right? If we get out our calculator and I want to find the sine of pi over 11 squared, here's what we're going to do. Okay, first of all, please check the mode on your calculator, right? You need to make sure that you're paying attention to what mode it's in. We want it in radians right now because that's what our angle measures are in. So I'm going to go in here and I'm just going to do the sine of, and if you want to type it in as a fraction, you can, or I'm just going to do second caret to get my pi divided by 11. That is a fraction, okay? Now, on our calculator, we will type it in this way. Okay, just make sure that that exponent is outside those parentheses. When you hit enter there, that's the answer you're going to get, 0.7937. We'll write that on here. So we have 0.0793. No, wait. Yes, that's correct, right? 37. So that's probably extra decimal places there, right? If we're rounding to 4 decimal places, it'd probably be just 0.0793. All right, so, but you see where that came from. Just make sure you put your exponent in the right spot if you're doing it on the calculator. Let's move that off of here for a moment. Okay, now we have the tangent of 2 pi over 3 squared. Okay, so we've already kind of gone through the sine and the cosine of this one. So just thinking about this one more time, since we're on a different page, right? Remember tangents down here, and we're talking about 2 pi over 3. So here's our pi over 3 angle. We're talking about over here in the corner, right? So what we see on our reference chart when we do that is going to be the square root of 3. So our tangent of 2 pi over 3 is really the same thing as the square root of 3. And when we square that, we get 3. So that would be the answer on that one. And then the next one, we have 2 that we've already done, right? The sine of 2 pi over 3 squared plus the cosine of 2 pi over 3 squared. Well, since we already did those, right, let's jump back here. So 2 pi over 3 we said was 3/4. And then for our cosine value of it there, we said it was 1/4. So this is the same thing as saying 3/4 plus 1/4, which is just going to give us 1 in this case. Right? And remember, this is what we call the Pythagorean identity. We talked about it just a little bit at the start the other day. Okay, so this is an example of it. Anytime we're doing the sine squared of an angle plus the cosine squared of an angle, that same angle, right? Anytime we do that, we know that we're using the Pythagorean identity, and it's always going to end up equaling 1. Okay, that's a major shortcut for you there, and it's something you're going to use to do a lot here in a couple days. So let's jump on to the next one. If I ask you to do the sine squared of 70 degrees plus the cosine squared of 70 degrees, okay, that one we already know is going to equal 1 as well. And let's check it out on the calculator once. Right, if you typed it into the calculator, this one's in degrees, so I need to switch it back to degrees. Right, if I do the sine of 70 degrees squared, where's my squared at? There it is, sorry, lost it for a second, plus cosine of 70 degrees squared, right, you see we hit enter there, we get 1. Okay, so the calculator's smart too. It will do this what it's supposed to do with that. Here's the thing that sometimes happens though. when people don't recognize the fact that, hey, I've got two different angles in here. If we have two different angles, it does not equal 1. Okay, so our sine squared of pi over 3, if we're trying to find that value, right, it's like the sine of pi over 3, and we're squaring that, plus our cosine of pi over 4 squared. So the sine of pi over 3, okay, so remember that's our top row and third column. We get radical 3 over 2 squared. Remember, this is just first quadrant. So that gives us 3/4, just like it did in that previous problem. And then when we add to it cosine of pi over 4, well, that's our middle row and middle column. We'll get radical 2 over 2. And when we do that and we square it, we should get 2/4. And I didn't reduce it because I know that my first angle was 3/4. So when I do that, I'm going to get 5/4. So this one has a value of 5/4, or 1.25 if you want to write it like that. That's totally fine. Okay, but that one's different because the angles that we're substituting in are not the same angle. All right, let's move on. We got a different question here. It says, if f of x equals the tangent of 5x minus the sine of 5/4 x squared, find f of theta. This one looks all super complicated and everything, but really, we're just taking it and substituting in pi as our input value, right, for our x's. So when we do that, we are going to say f of pi, oops, that's supposed to be in black there, we go. So it's equal to the tangent of 5 pi minus the sine squared of 5/4 times x is like saying 5 pi over 4. So what we need to do is just come up with the values of these expressions, and then we can get our answer. So thinking about the tangent of 5 pi, remember, all of our odd numbered pi's are going to be on the left side on the x-axis at that point, -1, 0. So the tangent is going to be equal to that ratio of y over x. So we have 0 over -1, which is just going to give us 0. So the tangent of 5 pi is equal to 0. For our sine of 5 pi over 4 squared, right, if you want to look at your 1, 2, 3, 3, 2, 1 chart, you can. Right, if I look at it here, I'm going to do just a little tic-tac-toe so you can get an idea. Remember, sine is on the top, and our pi over 4 angles are in the middle, so you're talking about right up here at the very top. Okay, so that is a radical 2 over 2. Now, 5 pi over 4, when we think about what quadrant that's in, right, I'm going to draw that on here. We've got 1/4, 2/4, 3/4, 4/4, 5/4. So that's down in the third quadrant, and we know sine is negative down there. So this is a negative radical 2 over 2, and we're going to be squaring it. So we'll take that, and we'll square it. So negative times negative is going to be a positive, and then we have 2 over 4. So it's like 0 minus 2/4. In this case, we can go ahead and reduce that to 1/2. So 0 minus 1/2. Remember, this minus came from up above there. It's not the minus that was down here. So 0 minus 1/2 is going to give us -1/2. So f of pi is going to equal -1/2. Okay, so with these ones, just take your time, find the value of each part of the expression, right? And then put it all together to get your answer. These ones say find all values of theta that satisfy the equation over the interval from 0 to 2 pi. So remember, we're going to include 0 here, but we are not including 2 pi in our answer. So this is just meaning on our unit circle, when we take it here and we draw it, okay, we're looking at just on one revolution, or from, as we start here at 0 and we go around all the way around the circle here to 2 pi, Okay, what would all of our answers be? And remember, we're not going to include 2 pi, but we will include 0 as a possible answer choice. So we're talking about the sine of theta is equal to negative radical 2 over 2. Well, we know negative radical 2 over 2 ends up being down here, right? That's the value of it. So when we're talking about what angles is this going to be, right? When we open this up, it would end up being here and down here. So there's more than one answer that we'll end up with. Okay, so we know that this angle here, when we count around here, this is going to be 5 pi over 4. Okay, and then the one on the right side there would be 7 pi over 4. If you look at the unit circle and look at their y-coordinates, both of them have a y-coordinate of negative radical 2 over 2. So that means our answer here for theta is going to be 5 pi over 4 and 7 pi over 4. Looking down below, it says find all values of theta that satisfy the equation over 0 to 360. So this is the same kind of problem, except now we're talking about in degrees. Okay, so if you want to take it here and draw out your unit circle, you can do that. But just remember, your domain that you're looking at here is going to be from 0 degrees to 360 degrees. You'll include 0, but you're not going to include 360 in your answers. So when we're talking about the cosine of theta equals 1, okay, that means that our cosine value has got to be positive 1. So that is this point right over here on the right side. So when we're looking at what is the answer to this, right, we will use 0, but we won't use 360 because 360 is not included in our domain. So we're going to say this one, our theta value, is going to end up equaling 0. I'm going to put 0 degrees, so maybe it looks a little cleaner. All right, so that's all for this lesson. Hopefully this makes sense. If you have questions, please, please, please make sure you reach out. If you don't understand this part of it, it may make some of the rest of it much more challenging. Thanks for watching.